Subheading, equal groups. Equal groups. Just like we had problems about separating things and combining things, this one's about equal groups, and I will just go out on a limb and tell you right off the bat here, these are multiplication pattern problems. Multiplication pattern. Now, as I said with the addition and subtraction pattern ones, please listen to me carefully. Just because it is a multiplication pattern problem does not mean that you will always multiply to find the answer. That's a great point, Mr. Hahn. Thank you for sharing that with us today.
Thank you. That's a great point.
Now, here you go. See, you always miss your opportunities to get that in there. Here is how the multiplication pattern works. Okay, it works like this. You have the number of things in each group. You have the number of things in each group, and then you multiply that by the number of groups. And when you do that, you get a total. Now, rather than probably writing out all those words, we will abbreviate a little bit. Because of the overabuse of the hashtag, we'll just do hashtag in group times of groups equals total. Isn't that smaller and much more concise? So this is the pattern that you are looking for. And I understand that some of you are still very, 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 very much more intelligent than actually doing this. Just humor the book, humor me, humor us all. And do your job. Now, let's write down an example of this here. An example for you and me, ladies and gentlemen, would be this. There are 4 classes of 5th graders. There are 4 classes of 5th graders at Bob Schnaub Middle School. Wait, no, grade school. Each class has, what does each class have? 30 students. In it. How many total students are there? Or total 5th graders, I should say. Total 5th students. I am going to let that sink in, and again, as I will tell you many times, it doesn't impress me that you know the answer right off the bat. Can I tell you that? This is not about just saying, oh, I know the answer. This is about saying, oh, I know the pattern, and I know how to fill it in, and then I can get the answer. I'll give you a chance to write that down. Number in group times the number of groups. I don't like orange because orange is not very clear. Okay, 5th grade.
I just don't like it generally.
Here is what we must consider here. Nowhere in our story problem, Max, when we're getting, does the word group appear. Does it? Do you see the word group there? No. So your job being what? 10, 11-ish years old? Or 12, I guess, or some of you will be able to drive next year the way it seems. You have to pick out which word in here is a synonym, means the same thing as a group, or is a group of something. Now, since you've had Miss Young for numerous years now, or at least 3 months, you know which words in here are nouns because the word group is a noun. So, we've got this. Here's a noun. Here's a noun. Here's a proper noun. Oh, that's all one big proper noun. Bob Schnapp Grade School. This should probably be a capital G there. There's a noun, there's a noun, there's a noun. So the question is, which one of those means a group of something? Is a fifth grader a group of something? Is a class a group of something? Is Bob Schnapp Grade School a group of something? Is a student a group of something? What is a group of what in this problem? You probably could say Bob Schnapp Grade School is a group of students, but that's not really what we're going with this one. What is a group, Andrew? A class is a group of, yeah. So you could change all these words classes and just kind of write in the word group. Group. And we're going to fill in the blank here. Do we know how many students are in every, instead of group, class? How many students are in every class?
30.
Right here. It says each class has 30 students in there, so we fill that in there. Do we know how many classes there are?
Yes. 4.
I believe it's 5 or 4. Yeah, 4. So bam, then to find out how many total there are, it's just simply multiplying those together, and we get 120 what?
5th graders.
Yeah, 5th grade students. Bob was a good guy. Okay. Now, here's one that is not quite, this one is not quite as easy maybe. Write this one more example problem down. This is for all you athletes out there. Oh wait, no, we'll do 2 more. The coach separated the 48 players into 6 teams evenly. 6 teams evenly. How many players were on each team? How many players on each team? And here again, I know at least probably 70% of you already know the answer. Because again, I wish I could congratulate you and say that is great, but here's what you want to think. And most of you have already gone, well, this is a division problem, right? How many of you already thought that? So to which you're going to say, how does that even play into what we're doing? Because nowhere have I seen division yet. Well, children, you are separating things into groups. And if it's a grouping problem, it's a multiplication problem. It's a multiplication pattern problem. That doesn't mean we multiply. That's what I told you before. But we're going to write down the little thing here. Remember, it is hashtag in each group times hashtag of groups equals total. To which we have to figure out what word over there stands for a group of something. Is a player a group of something? Is a team a group of something? Is the coach a group of something? Which one is a group of something? Colin?
Team.
A team is a group of players, right? So the number in each team, I should change colors so that will stick out. Number in each team times the number of teams gives me total. Do I know how many are in each team? How many people are going to be on each team? Don't give me the answer. Does this tell you how many players are on each team? No. So that's where you put the letter P for players. I don't know that yet. How many teams do I have? 6. And how many total players are there? 48. This, ladies and gentlemen, is by far more important to me than you actually getting the right answer. Because that shows me you understand what the pattern is to be able to do harder problems, because these numbers are really easy to work with. And then when you have a missing number, remember you're supposed to think of an easy multiplication problem. Let's say 7 times 2 is 14. If you don't know this is a 7, what do you do with those 2? Here's where you do the division, because 14 divided by 2 is 7. 48 divided by 6 is 48 divided by 6 is 8, which would be your answer to the letter T. Right, P. There are 8 players on a team. Sorry to bore all of you that are yawning out there, but You ready for the super challenging one? This will tell me if you are highly academically, mathematically challenged or just severely mathematically challenged. Marilyn, what's your thoughts on that? Highly or just severely? Good question, isn't it? Very good question. Write down one last one. Monica raked leaves and filled 28 bags. Monica, let's just say she filled 28 bags of leaves. Where's this problem going? I don't know. On each trip, she carried away 4 bags. On each trip, she carried away 4 bags. How many trips did it take Monica to take away all the bags? How many trips did it take? And again, I know, right now people are going, I know the answer to this. No matter to me. We are separating this into some groups here. Number in group times number of group equals total. Now here is where we're going to run into trouble here. What word in there, in that sentence, is a group of something? Now let's look at all the nouns in there. It looks like Monica's a noun. She's probably not a group of anything. Bags is a noun. Leaves is a noun. Trip is a noun. Bags, trips, take, boom. What is a group of something? Ooh, Marilyn.
Leaves.
Leaves is a group of...
Leaves.
Yeah. Did you say leaves? Did you say leaves was a group? No. Yeah. Leaves is not a group of anything. A leaf is actually a single unit that a plant uses at this time of year. Jacob.
Bags.
A bag is a group of what?
Leaves.
Now, here's the question, and maybe it is, but are we looking for how many leaves are in every bag? So that's probably not, while there is, I mean, if this would have said that she had 8 billion leaves and she had them in 28 bags, then yes, the bag would be a group of leaves. But that, in this case, is not. Something else is a group of something. And you're not the first 5th grade class that's been stumped by this problem. But you may be the last. Brian.
28 divided by 4 is equivalent to 7 trips.
Okay. Victoria. Which word there stands for a group of something?
Trips.
A trip is what? A group of?
A trip is a group of 4 bags.
Exactly. Exactly. The word trip is what we are using for our groups, because a trip is a group of 4 bags. Do we know how many are in each group, or how many we take in every trip? Yes, what is it? How many in every trip?
4.
There you go. Do we know how many trips we're taking?
No.
Nope, so we put the letter T there. And then we get a total number of 28 bags in all. And again, this is just like the beauty of a multiplication pattern problem is if you're missing any of the factors, you always divide. So, but we think of an easy problem, 5 times 4 is 20. If I'm missing this, what do I do with 25 to get 4? Divide. And as Brian will tell you, 28 divided by 4 is 7. It will take you 7 trips. How about that? One of the reasons I'm sure you throw the love in the door